So we are going to see push down automata basics in this video. So PDA push down automata, so it is informally defined as a finite automata plus stack is equal to a PDA, right? Now the formal definition is the same formal definition of in spite of all these 7, right? So this belongs to the stack and this belongs to the stack. Apart from that, the other 5 or belongs to the finite automata, right? So set of states, then set of input symbols, then here this is set of stack symbols, and then transition function, then initial state, stack top symbol, and then F is final state. Now, so this is the formal definition, right? This is the informal definition, this is formal definition, and graphical notation is diagrammatic representation of the PDA is called as graphical notation, where we have to give an example of a PDA like this, and then you have to explain that what is this symbol used for, right? The circle, right? Now when it is double circle, it is final state, and it is initial or intermediate states, a single circle, then the arcs used for and how the representation is mentioned actually, right? So these things has to be explained when you are being asked for the graphical notation, right? So in the same manner, fine, or the symbols used in the diagram, fine. And then for instantaneous description, you have to specify the transition function. This is transition function of a PDA, right? So what is the transition function? It will be in some state where a input is read and on the stack a symbol will be present. So in this combination, now having this input, right? So what should be the next state and the stack operation? So that is the transition function of a PDA. Whereas instantaneous description in the sense, instantly we are specifying the acceptance of the string. So W specifies string, right? Now, so how it is specified? So any state, so current state and the input, and followed by the rest of the string, and then the stack operation, right? And stack operation, the remaining, fine. So the same manner, this is turn still, so which will be more in number until acceptance, we will be utilizing it repeatedly, right? So if we take an example, right? So say for example, so Q0, 1100, Z0. Say this push down automata is for checking whether equal number of ones and zeros are present. So what will be the condition here? So when it is reading ones, it should be pushed inside the stack. So Z0 will be on the top. So when it is reading 1, it should be pushed into the stack, right? And when it is reading zeros, right, the PDA, then this should be popped off. Then when second 0, this should be popped off. Now since there is nothing in the stack is empty, the in stack symbols are empty, only Z0 is available, this will be reaching into the final state. So we can specify that the string is accepted by the final state. Now how to write the instantaneous description here? This methodology we have to follow, where turn still, then Q0, so on reading 1 first, right, the remaining strings to be specified, and what is the stack operation? 1 will be pushed in Z0, right? And again Q0, on reading the next one, what will be done? It will be pushed the remaining string, so 1 Z0, right? Now what is the next thing? See, it is in the same state, right? Now when it started to delete, it will be having a state change, right? So on reading the 0, fine. Now what will happen? Remaining 0, then 1 has been, this 1 has been popped off, so remaining 1 and Z0 will be remaining. And then again Q1, what is this thing here? It is that this input, now the input is empty, completed, and then what is the stack operation? This 1 will be popped off and remaining is Z0. Now string is empty, There is no more input to read and the stack is Z0. So in this condition we say that the accepted by the final state. So this is called language acceptance, right? So QF comma Z0. Fine. So the next one is language acceptance by the PDA. So two types it is of. One is language accepted by the empty stack. That means our complete stack of the PDA is empty. Not even the symbol Z0 is present. Right? Now, when we say that the language accepted by the final state, then we say that it is Z0 will be present and the machine has reached to the final state, right? Now the general meaning of this is, right, so for the empty stack, this is the description of the transition function. So for any string, when it is in a state, then the string is there, this is transition function condition, right? So Z0 is on the top. Now after the instantaneous description, right, now it reaches the condition that it is in some state, then the input is null and then the stack is also null, right? So this condition, right, stack is also null, right? So this condition we call that the string is accepted by the empty stack. Whereas example, so if maximally in many of our condition this will be, we have to specify. So in some state, that is Q1 here, where null is the input, there is no more input, it's complete, and then Z0 is on the stack top. So where it is going now? So it is in Q1 state and it is null. Stack top has been, Z0 has been popped off. Now the stack is empty. So we call this is string accepted by the language accepted by the empty stack in the PDA. Now when it comes to the final state, right, so stack top, that means it will be holding the Z0 here in the transition function, whereas it has reached the final state. Okay, so string is completed, same condition, but here we will have a stack symbol, top symbol. So that Z0 is the default one. So the example is Q1 null Z0, where it reaches the final state and Z0 on the top. Can you see the difference between the two? Right? See, this left hand side transition function is same. In the right hand side, if Z0 is not there, you have nullified it, then we call it as accepted by the empty stack. Whereas when QF, that is the final state, and Z0 is present, we call this as accepted by the final state. Right? Thank you.